Hello, good day. This is Exponential Electronics. Today, we're going to learn about the power board of a LED TV. This is a power board for a LED TV, 42-inch LG. The power board is different from the main board. The power board helps to supply the necessary voltage that is required by the main board to function in an LED or LCD or in an electronic gadget. Without the power board, it will be difficult for any electronic to function. In some cases, the main board contains both the cold region and the hot region. But unlike power board, it contains the hot region and the cold region as well. But it does not have a unit for input and output. From this power board, let us start by identifying the components in our power board. This is where the power will go through, the AC voltage will go through. Then the AC will pass through a coil. It will pass through coil and it will also pass through fuse. From this diagram, this is where the fuse should be connected, but for this board, the fuse has been removed. It has been removed. The voltage will pass through this fuse, to pass through this AC capacitor, ceramic capacitor, to also pass through those AC capacitors. Those ones will help to filter it. To pass through this resistor. This is a resistor. Then it will move down to this side to go like this down to the rectifier. Now, what is the function of rectifiers? These are two rectifiers. They convert the AC to DC so that the rest of the component of the board will enjoin their functions. From this part, from these rectifiers, these are rectifiers, you can see them. To pass through these rectifiers, then pass through this diode. This is a Schottky diode, very fast. This is a diode. Pass through diode, and it will also, through the help of this diode, the voltage will be moved down to this other diode. This one is a diode as well. Then the voltage will move straight to our capacitor. This is an electrolytic capacitor. This is a power capacitor. You can see the rating. The rating is 500 volts and 100 UF. UF means 100 microfarad. When this one is defective, you can replace it with that of 86. 86 will also work. 86 UF. You can use it to replace that of 100 UF, but make sure the voltage is up to 500 volts. Then it will pass through these electrolytic capacitors and enter inside this fuse. Yes. Then from this fuse, the aim of this fuse is when things are going wrong, when the other components are consuming current more than they should consume. This fuse will help to cut, to create an open circuit for the current not to cause more damage to the system. Now this voltage will pass through this level. Now the voltage will pass down to this side, to this octocoupler. Through the help of this octocoupler and through the help of this controller chip, the PFC, power factor correction, will be able to signal this voltage and pass it to the DC area. Now these are some of our rectifiers for the DC. You can see them, and these are the jumpers, the resistors, and the MOSFETs. Those MOSFETs help to supply voltage that will drive this choke. So they will drive this choke, and the power will pass to those capacitors. The electrolytic capacitors will filter it. And once they are filtered, the voltage will be passed across down to the backlight. Those ones are meant for the backlight. These are electrolytic capacitors to stable the voltage for the backlight. Meanwhile, this voltage will pass through those diodes. You can see them. Those diodes, they are light in parallel. It passes the voltage down to this backlight sockets through the help of this rectifier and through the help of this driver. This is a IC that drives the voltage for the backlight. Then for your DC to DC, we have our DC slots. From the DC slots, this voltage pass through these rectifiers. These are through those octocouplers. Those octocouplers that are connected in series. They are connected in parallel. So those voltages, let's turn it back. Let's turn it back and see. Yes, they are connected in parallel. They are connected in parallel. Those are the octocouplers. So those octocouplers, they help to stabilize or to boost the voltage for the DC units through the help of this PFC. This PFC is also for the output DC units. You can see the rating. These are the rating. We have the 12 volts. We have the 12 volts. We have the ground. We have the 3.5 volts. We have the PDIM2 and PDIM1. We have the power on. We have the power on drive. We have the power on drive. And we also have the 24 volts units. In my next class, I'll teach you how to start up the power board for the LED drivers to pick up, and also how to activate the 12 volts power unit. So this is a brief analysis of the power board. These are electrolytic capacitors for the output voltages. These are diode. These are fast switching diode. They are called them Stockish diode. Yes, and these are coils. Some are power factor correction coil, just like this, and this power factor correction choke. This is an electrolytic capacitor, very strong for the AC units. Some of them are used for the DC line as well. So that is just it. Thank you for this video. Do well to subscribe to my YouTube channel, to Exponential Electronics. Thank you.